Hey team, I'm Maddie. Welcome to Science Side Up and our first look into the 2021 IPCC report. The Intergovernmental Panel on Climate Change, or IPCC, released their latest report in August of 2021, free and available to the public, links in the description. And August 2021, that is when I wrote the script. That is probably not when this is airing, but hopefully it's close. As an aside, I have seen some videos on YouTube reading through and reviewing the IPCC report, and the ones I've seen all seem to have headlines of like, it's worse than we thought, and other dramatic things. I don't know about you guys or just non-climate scientist folks in general, but from what I've read in this IPCC report, like it's not worse than we thought. It's exactly as bad as we thought and have been saying for years. So I don't really know how to feel about either that fact or the clickbaity titles, but me reading through this, I'm just like, no, it's still terrible. We should definitely be doing something about this. The full IPCC report is 3,949 pages. I have not read all of that yet. But part of that full report is the 40-page summary for policymakers, and I am finding that to just be an absolutely excellent document. I think the language in it is very understandable to a non-specialist audience, and it's short and to the point. It gets the information across succinctly and well. So what we're going to do today is read a few statements pulled directly from that summary for policymakers, and then dig into the evidence for those statements. And my goal for this video is going to be what are the key takeaway points from the full 4,000-page report. So that's what we're going to do today. Yeah. We're going to start with section A1 from the summary for policymakers. It is unequivocal that human influence has warmed the atmosphere, ocean, and land. Widespread and rapid changes in the atmosphere, ocean, cryosphere, and biosphere have occurred. Y'all, that has this energy. This is as sassy as scientists are allowed to get. This is sassy. This is like, get your tea and watch this drama unfold levels of scientific discourse, and I'm kind of here for it. You'll see what I mean as we get into more of these statements, but y'all. The next section we're gonna read, A.1.2, gets into some of the details for how much have things warmed. Each of the last 4 decades has been successively warmer than any decade that preceded it since 1850. Global surface temperature in the first 2 decades of the 21st century was 0.99 degrees Celsius higher than 1850 to 1900. Global surface temperature was 1.09 degrees Celsius higher in 2011 to 2020 than 1850 to 1900, with larger increases over land than over the ocean. The estimated increase in global surface temperatures since AR5 is principally due to further warming since 2003 to 2012. Additionally, methodological advances and new datasets contributed approximately 0.1 degrees Celsius to the updated estimate of warming in AR6. 2 quick things. 1, AR5 and AR6. AR6 is just the shorthand, the abbreviation for the report that we're reading right now. This is the IPCC report version 6. And AR5 is the last report that they did. I'm pretty sure that came out in 2011. Second thing, I wanted to quickly note the difference in warming of the ocean versus the land. So that difference is 100% expected and predicted by just basic physical properties. So water has a pretty darn high specific heat capacity, which means that it's harder to raise the temperature of ocean water than it is, for example, land that's next to it. Very well-known fact, and so that result that they have, that the land is warming more quickly than the ocean, very well understood, and not surprising at all. So that section was a little drier, but this next one, the sass comes back, and I'm so excited. The likely range of total human-caused global surface temperature increase from 1850 to 1900 to 2010 to 2019 is 0.8 degrees Celsius to 1.3 degrees Celsius, with the best estimate of 1.07 degrees Celsius. It is likely that well-mixed greenhouse gases contributed a warming of 1 to 2 degrees Celsius. Other human drivers, principally aerosols, contributed a cooling of 0.0 degrees Celsius to 0.8 degrees Celsius. Natural drivers changed global surface temperature by negative 0.1 to 0.1 degrees Celsius, and internal variability changed it by negative 0.2 to 0.2 degrees Celsius. It is very likely that well-mixed greenhouse gases were the main driver of tropospheric warming since 1979, and extremely likely that human-caused stratospheric ozone depletion was the main driver of cooling of the lower stratosphere between 1979 and the mid-1900s. Team, this is, I don't know if the language is coming across as strongly to you all as it does to me, but to me, this is scientists banging their heads against a wall, trying to use as strong of language as they can, but like, you're not allowed to curse in science journals or reports from the UN, turns out. If they could, this would be littered with them, because that is the attitude we've got going on in this report. Okay, let's dig into some of their science. If you guys have watched my videos, you know that my favorite question on planet Earth is, how do you know that? And so we're going to take a look at some of those claims in those three statements we just read and ask the question, how do they know that? And luckily for us, this is an incredibly well-cited document, so we can go look right this second at how do they know that and convince ourselves. These are the pages and pages in the full report that detail all of the methodology and data sets and results and all of that very good stuff that was then distilled down into those three statements we just read. And the most important part of that are these pages of cited work. I love citations, they make me so happy. But I think the graphs on the next page do an excellent job of showing us how we know how much of climate change is caused by human activity. To the graphs! Both of these graphs show how temperature has changed from year to year. The left plot covers the last 2,000 years, and the right plot is just from 1850 to 2020. From 1850 forwards, we have consistent human records of global temperature, but before 1850, when those records were either inconsistent or entirely non-existent, we have to rely on paleoclimate proxies. The lines on that graph represent a sort of best estimate, and the shading represents error bars. The real value could be anywhere in the shaded region, but it's probably at the line. Let's focus in on that 1850 to 2020 graph. Notice we've got three colors here: green, brown, and black. Black is the observations, and green and brown are both climate model data. To get the green curve, they ran their climate model but kept human-generated greenhouse gas emissions at pre-industrial levels. To get the brown curve, they ran the exact same computer climate model, but included those human greenhouse gas emissions. And the takeaway is that it's the model with included emissions that best captures the observed behavior of the atmosphere. That supports our big number one takeaway. The best and frankly only way to explain what we are actively seeing our atmosphere do is from human contributions of greenhouse gases. That's the answer. That's been the answer all along. Another important point here is that both of those climate model simulations account for the same natural variability. Natural variability is a common talking point amongst climate skeptics. The question they pose is, how do we know that what we're seeing the atmosphere do isn't because of natural processes? Well, this is how we know that. Natural processes can't account for the changes, but human greenhouse gas emissions do. Now we're going to move on to another graph that I think really just does an excellent job of breaking down all of the ways humans are affecting the climate and showing those graphically. So let's take a look at this. That left-hand panel with the gray bar is showing us how much we have observed the planet to warm. So it's right at 1 degree Celsius, and then that black bar represents the error bars. So it could be a little less than 1 degree Celsius, a little bit more, but it's right around 1. The two graphs on its right are showing the same type of data presented in the same way, but from two different sources. So two different methodologies to kind of ask the same question. And the question that they're trying to address is, hey, break down all of human emissions, piece by piece, how much are each of those pieces contributing to warming? So let's look at that chart B. In this graph, that first bar on the left, that's just repeated, that's observed warming. Then the next bar graph is for well-mixed greenhouse gases. So if nothing else was going on in the atmosphere, then our well-mixed greenhouse gases should have warmed the atmosphere by 1.5 degrees Celsius, with error bars allowing that to be as high as 2 or as low as 1. Biggest note here is that greenhouse gases left to their own devices would be warming the planet more, but there's other processes going on, and lo and behold, many of those processes are actually cooling. That next bar graph shows us other human drivers, so other pieces of pollution, really, that have caused net cooling. So if we kind of separate human emissions into greenhouse gases and not greenhouse gases, then the greenhouse gases are causing warming. Other factors would be causing cooling. Now, before everybody gets all excited and is like, hey, can we just pump a lot of those other things into the atmosphere? While they might be mitigating global warming, these are still not things you want to breathe, right? These are aerosols that can very much make you sick. And if we sort of add that blue bar with the greenhouse gas bar, we're gonna basically get the overall trend. Here's another nail in the coffin for our natural processes, folks. Notice that solar and volcanic drivers and internal variability. Internal variability is just other things that are happening naturally that we don't strictly have a name for. Those did nothing. Their error bars extend above and below 0, but they average out to nothing. So that global warming is, again, very much human caused. Now, jumping over to this last graph, these have all of those components broken down even further. So instead of just saying well-mixed greenhouse gases, Now we get a separate bar for carbon dioxide and methane, nitrous oxide. Notice there that our big culprits are carbon dioxide and methane. Exactly what anybody watching this video probably learned in elementary or middle school. Notice that that main component of the cooling is sulfur dioxide. That's the same kind of stuff that erupts out of volcanoes, and it happens to be very shiny, so it's good at reflecting sunlight away. Once again, you very much don't want to breathe it. There's a little bit of common sense there. You wouldn't just stick your head into a volcano and breathe in that noxious gas. So hopefully this graph really shows you guys how well we understand these processes, how well documented and researched they are. Climate scientists aren't scrambling around in the dark. They're not making things up, right? This is incredibly well-backed science. And you can see it for yourself. It's also free and publicly available. IPCC isn't even behind any kind of paywall. Again, linked in the description. To finish out this video, I want to talk very briefly about stratospheric ozone. In section A.1.3, the last sentence we read says that human-caused stratospheric ozone depletion was the main driver of cooling of the lower stratosphere between 1979 and the mid-1900s. And I want to talk about that bit because I think it might be just a little confusing. We live and breathe the troposphere. That's the lowest layer of atmosphere. It's the part of the atmosphere that touches the planet. And the layer above us, where we live and breathe, this layer, is the stratosphere. It's actually pretty difficult to exchange air between the stratosphere and the troposphere. Another weird thing about the stratosphere is that as you increase height through the stratosphere, temperature actually goes up. That's not what happens down here in the troposphere, right? When we go up, when we climb Mount Everest, it gets very, very cold. I've never climbed Mount Everest, but you get the point. The reason that the stratosphere warms with height is because of the high presence of ozone. And in a nutshell, we want ozone in the stratosphere, we don't want it in the troposphere. Ozone is really good at absorbing UV and other high energy rays from the sun. So ozone in the stratosphere, what it does is it traps some of the most harmful sunlight and prevents it from ever getting down here to us, where it would cause things like sunburns and, even worse, skin cancer. So cooling in the stratosphere, one, is bad because it means that we're depleting that ozone, so more and more UV is getting through down to where we live, and that's not where we want all that UV. We want it not where it can burn us. But also, the stratosphere cooling doesn't affect the temperature of the troposphere. So cooling the stratosphere is not a good thing when it comes to global warming. It's kind of like two separate problems. One, the types of pollution that remove ozone from the stratosphere, those are like chlorofluorocarbons. That's a completely different type of thing than what causes warming in the troposphere. And two, that cooling of the stratosphere doesn't give us any secondary benefits. Again, it's not cooling the air where we live and breathe. Another very cool thing is that our ozone hole is fixing itself. This is because of policies that were put in place under the Nixon administration. It took decades of human behavior, of human pollution, to noticeably affect ozone concentrations in the stratosphere. And now it's taken decades of human behavior to start to fix it. A few final thoughts. One, the IPCC report is not messing around. They are communicating this as strongly as they know how. God bless them. The main conclusion of the report is what we looked at today, and those main conclusions are: the planet is warming. It's our fault. And the other conclusion that we didn't get to today is the consequences of that warming are going to be bad for humans. Where there can be ambiguity is exactly where is it going to be the worst for humans, how bad is it going to be, and when is it going to get that bad? Those are the open questions. Whether or not climate change is being caused by humans is not an open question. Climate change is caused by human emissions of well-mixed greenhouse gases, mostly CO2 and methane. Yes, a lot of our sources of methane come from livestock, but we wouldn't have that many livestock if it wasn't humans raising the livestock to feed humans. Don't at me. I know cows aren't people. Team, please let me know down in the comments if you liked this video. Is this what you were looking to see? This video and a video like this is a lot of time and energy on my part. So if this is good content for viewing, and if people are learning stuff from this, then I'm more than happy to do more, but it's a lot if people hate it. So please let me know. Thoughts on future videos around the IPCC report would be digging into more of the specific consequences, answering that question of how bad is it gonna get for people. And we'll kind of do it the same thing, just take it bullet point by bullet point, look at what they're saying, how they know that, and then provide you guys all of the resources if you want to double check my work, and you absolutely should. Always double check work. If there's other things in the IPCC report you're interested in, also leave that down in the comments. Again, I just really appreciate some feedback on this. So if you stuck it out all the way to the end, thank you so much. You're amazing and cool. Okay, so that's it for this video. You guys are amazing. I will see you next time. Bye, team. That was really dramatic, and it was fine. It was normal. It's a normal human thing for humans to do.